Hello, welcome to Math 1324. This is Chapter 10, Section 3, Example 5, I believe. And here we want to find any horizontal and vertical asymptotes. That's weird. And any holes that may exist for the rational function. We want to draw the graph of the function, including any x and y intercepts. Okay, so I want to go ahead and begin with, well, let's just talk about the domain. Since this is a rational function, the domain is anywhere where the denominator is not equal to 0. So here, if we take the denominator, say x plus 3, set it equal to 0, well, technically not equal to 0, and solve, that means that x is not equal to negative 3. On the number line, if I was to draw that, it means I can use any number to the left of negative 3, excluding the negative 3, and any number to the right of negative 3, excluding that negative 3. So the domain here will actually be negative infinity to negative 3, and then union negative 3 to infinity. Now, this is important because this helps us find vertical asymptotes, usually. So let's talk about vertical asymptotes. For vertical asymptotes, if f of x equals p of x over q of x, where no common factors exist, for p of x and q of x, then vertical asymptotes exist where q of x is equal to 0. In other words, where the denominator is equal to 0. And for this particular question, you should notice that negative 5 in the numerator, x plus 3 in the denominator, there is no common factor. And so as a result, for this particular question, the vertical asymptote appears wherever x plus 3 is equal to 0. So it's actually very similar to what the domain is here in this particular question. So the vertical asymptote is x plus 3 equals 0. In other words, solve for x, you get x equals negative 3. So the vertical asymptote here, abbreviated as VA here, is x equals negative 3. And a vertical asymptote is a vertical line through which the function cannot pass. Think of it kind of like a brick wall. And it's not actually part of the function, it's just kind of an imaginary vertical line. And so it's going to be important for you to recognize that. Second of all, when you draw vertical asymptotes, we draw them with vertical dotted lines because, well, frankly, they don't exist as part of the function. Okay, so there you go. Those are vertical asymptotes. Horizontal asymptotes. We need to look at those. Horizontal asymptotes are a little bit different. Horizontal asymptotes are where, or what is the function doing as x gets really, really, really large or really, 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 really small. And we've actually kind of already talked about this a little bit in the sense that in polynomial functions, there aren't horizontal asymptotes per se, but we already talked about end behavior of the function. So this is really what we're kind of talking about here for a polynomial function. So, so what I'm going to do is I'm going to let m equal the degree of the numerator. You know what? No. I'm going to let n equal the degree of the numerator. And I'm going to let d equal the degree of the denominator. So n is the degree of the numerator, d is the degree of the denominator. And if we go back up and look at the function, notice that for the function, -5 in the numerator, x plus 3 in the denominator. And I want to know what are n and d here. Well, the d can actually be can be seen pretty easily. Remember, degree is just the highest exponent that you see in the polynomial. So in the denominator, the polynomial is x plus 3. There is no exponent here, and my thing is doing some weird stuff there. Yep, that's all it's going to do. Anyway, it's a 1. It's understood to be 1. So the denominator's degree is 1. What about the numerator's degree? Well, in the numerator, there is no x here, so technically what we have is x to the 0 power. And notice the exponent there is 0. In other words, it's indicating that there are no x's in the numerator. So for this particular question, n is 0, d is 1. And the horizontal asymptote is going to depend upon the relationship between n and d. So what I'm going to say is, if n is less than d, the horizontal asymptote exists, and it is y equals 0. You'll find out y in calculus, assuming you're taking calculus. If n equals d, the horizontal asymptote still exists, but it's going to be a little bit different from 0. It's going to be the ratio of the leading coefficient of the numerator divided by the leading coefficient of the denominator. Good. And if n is greater than d, there is no horizontal asymptote. And generally speaking, we call this a slant asymptote or possibly an oblique asymptote. So it's one of the two names there. We generally call it a slant asymptote if the degree of the numerator is 1 more than the degree of the denominator. Otherwise, we call it an oblique asymptote. They're all oblique asymptotes if there are no horizontal asymptotes. But slant is more of a, shall we say, more specific. Excuse me. Never mind, I'm out of water. Okay, let's see what we have here. N in this case was 0, D was 1. Notice that between 0 and 1, the relationship is less than. And so in this situation, we have this happening, which means the horizontal exists. The horizontal asymptote exists, and it is also y equals 0. In other words, the x-axis. Awesome. Well, what else do we have? Draw the graph including any x and y intercepts. Frankly, to draw the graph, it's going to be easiest to use the calculator. So I'm going to go ahead and leave it there for now. I will say that the vertical asymptote definition is very important, that we have no common factors. And the reason that we have to say that is because if you have common factors in both the numerator and denominator, where that factor is equal to 0 actually produces a hole in the graph. So we have to be very careful about that. That is a possibility. Alrighty. Well, I will see you in the calculator. Hello. Welcome back to the calculator. And I'm going to go ahead and quit to the on screen. I'm going to go to y equals here because we need to graph this. This is a rational function. So my recommendation is to use alpha y equals nr. It's very important that you do this. The reason why is because, well, frankly, if you don't, you're probably going to make a mistake. Okay, so there you go. -5 over x plus 3. I'm going to do zoom 6 for the standard window, and there we go. Notice that this function is going up this way and it's coming from down this way. And that actually is the vertical asymptote here. Okay, so in fact, I wonder if I can draw that. Vertical line. Oops. There we go. Come on. Yeah, close enough. Yeah, that's it. Anyway, this on Pearson, I believe, would be a vertical asymptote, and it would be dotted instead of solid. So what's happening is this function is approaching this vertical line, and it's getting really, really close. But notice that it's actually going up towards infinity this way. And then it's starting on the other side going up this way. And notice that it's also approaching 0 going to the right and to the left. That's what the horizontal asymptote is telling us. So vertical asymptote, horizontal asymptote. And there are no holes in the graph. In this case, notice that there are no x-intercepts either. But there is a y-intercept, and it's going to be whatever that value would be, which would be -5/3 or -1 2/3. All right, well, that's pretty much it for now. I will see you in the next video. Have fun.